Thank you. Hello, good morning here from the icy cold and snowy Copenhagen. I'm really excited to be given this opportunity to talk to people all over the world about my ideas of how we can get early test involvement to the extreme. What I initially called this webinar was I don't want to be a tester anymore. So we'll see what I mean by that. First of all, I'll tell you a little bit about myself so that you can get an idea of the context I'm in. I'm 55 years old. My hair is light, and apart from that, I love product quality. I love products being well done. They don't have to be expensive. They don't have to be rocket science, but I like it when people have done their best to give me a good product. I've been in testing for many, many years, but I actually started out my career as a civil engineer, graduating from the Technical University of Copenhagen in 1979. After the first year as a civil engineer, it wasn't quite me, and I actually got a job in one of the big hospitals in Denmark in their IT department. They wanted somebody with an academic education. I had that. And it didn't matter if you didn't know anything about IT. I didn't know anything about IT, so I matched that qualification as well. From then on, I learned IT more or less learning by doing and by asking my peers. And I worked in many different companies. I went back to civil engineering company to work in their IT department. I went to Norway with BP. I went to London, still working for BP, and then I got a job in a communication company in London. That was in '86, and that was the first time somebody told me about testing for the first time. A colleague and me, we had put up a change to the live system, and just a few minutes after that, our boss called down from one of the customers and said to us, "You put some new stuff on the working system, haven't you?" Yes, we did. We made the change. And she said, "Did you test it before you put it up?" And we didn't know what to answer because we didn't really know what she meant by that. So she came back and taught us a little bit about testing. Then I moved on to work in France. And in 1991, I came back to Denmark to work for a company that supplied software to the European Space Agency. That was where I learned about requirements and testing, really for the first time in a structured way. And there were so many things I wish I had known before, but such is life. In 1992, I attended the first EuroSTAR, and I've been to all of them except two. So this is my 16th EuroSTAR. And I always enjoy it very much. And last year I won the EuroSTAR Excellence Award, so that made it an even more spectacular event for me. I have made training courses in ISTQB, both practitioner and both foundation and advanced. I've also made a course in requirements so that you can now get an IREP certification in requirements in Denmark. I'm also leading the first mandatory testing course in the IT University in Denmark. So I guess you can sort of get the idea that I'm really much into testing. And I've learned a lot about testers and about requirement engineers over the years. So what I have primarily learned is that testers are always unhappy. I've met so many testers frustrated and burning out and being unhappy with the conditions they were given. Sometimes in a project it looks fine from the beginning. You can work with your test, you can start talking to the developers. But as the project goes on, the testers get more and more squeezed. There's not enough time for them to do a good job, and they feel they have the responsibility for all the quality, for the quality of the product that comes out. They're frustrated because the requirements they have to work from are not well defined, they're not complete, they're not testable. So maybe it's generalization a little bit, but it's what I have learned about testers, and it's also what I hear many people grumbling about at EuroSTAR and other events, that it's really not easy to be a tester. And strangely enough, the same goes for requirements engineers. In the other end of the development life cycle, requirements engineers are also unhappy. They start out with all the best intentions in the beginning, working with their requirements, but most of them don't really know when the requirements are good enough. So they struggle, they try to do their best, and sometimes they're told that they're taking too long. Stop working on all those requirements. Let's start the real work, as if working with requirements were not real work in a project life cycle. So developers sometimes take over and just code what they think the customers will need, and that leads, of course, to very unhappy requirements engineers and not very well-defined requirements. So both testers and requirements engineers are unhappy, and I think we can't have that situation anymore. We need to do something dramatic to get people to like their jobs and to feel that they're fulfilling their jobs. So this is basically where I am today. I've had enough of testers being squeezed, not being given good context to work in, and I've had enough of requirements people not knowing when the requirements are good enough, when they're complete, when they're testable, when they're not contradicting each other, etc., etc. But it's not good enough just to lean back and say, I don't want to be a tester anymore, or I don't want to be a requirements engineering anymore. So what is it I want, and what is it I would like for both testers and requirements engineers and designers, for that matter, to do? Well, what I would like to do is for us to think about Boris Beizer's mental levels. He wrote those for testers, but they're actually applicable to all of us when we get to the mental level, or the phase 4. What Boris Beizer said many, many years ago, actually, is that he defined this scale going from 0. He was an IT person, so he started from 0 up to phase 4. What he defined was that phase 0 for a tester is when you think that debugging is testing. You play around with your debugger, you put in variables, you change them, you follow them through the code, you get some sort of result out and it looks good. So you feel that now you have removed the bugs, now you have done the testing. When you get into phase 1, when you know a little bit more about what does it mean to put out quality products, you think that testing is about showing that the software works. So you aim at demonstrating that the software is fine, that you can go through the happy scenarios, and that there are not many bugs found in the software. And at phase 2, in Boris Beizer's level here, you start to think that what you need to show is that the product doesn't work, that the software has bugs. So you aim at getting the software to fail so that you can see where the defects are. And in my opinion, that is where many of the exploratory testers are today. They really want the software to fall over, to get around into it and see if they can break it. At phase 3, Boris Beizer says that that is to reduce the perceived risk of the software not working. So this is where most of the testing society is today. It's still one of the hot topics at EuroSTAR and other conferences, and the most used approach today in testing is risk-based testing, where you define what the risk is of sending defects out, and you aim your testing at reducing that risk by finding as many defects as possible, geared by the risk profile you have. Then on to phase 4, where Boris Beizer says it's a mental discipline that results in low-risk software without much testing effort. Wouldn't that be wonderful if we could get this idea of not testing quality into products, but actually working it into the products from the beginning, if we could really make that work and get to phase 4, not just for testers, but for everybody in the development life cycle, to have a mental discipline that results in low-risk software, where we are disciplined professionals working together to make the product low risk and well fit for the customers. That is what I would really like to see. So going along those lines and thinking about what is it that we need to do, and working on test courses and requirements courses, what I found out was that what I really wanted to be was an expectation engineer, because both requirements people and testers are working with the expectations that the end users and the customers have. They expect something from the product, and we need to find out what their expectations are, and we need to find out to what extent those expectations have been met in the final product. So that we should work together as teams all the way through the development life cycle to manage and to engineer the expectations. So what does that entail? Well, what I think is that we should think about development as expectation engineering, all geared towards construction of the product. This slide here is showing that expectation engineering is supposed to be a team of people, not just one person, but still it's ranging from the very first idea in an organization, getting the ideas for the project, why are we doing this, what are we going to earn, and until the product is delivered. That can be a few weeks, a few months, it could be years in some context. The two people at the top are inspired by Belbin's team roles. I don't know if you are familiar with Belbin, but he has defined 9 ways that people contribute, or maybe not contribute so much, or actually take away from the way you work in a group. And I think on very, very general terms that people working in requirements are mostly of the Belbin type of idea creators. That is the person to the left. They come up with new ideas for things. They find out how this could work. They try to figure out what people want. So that is a specific type of people, or specific types of people like to work in requirements engineering. And in most testing, we actually see Belbin completer types. These are the types of people that like to put the final full stop in a document, that like to tie the bow on the project. Now it's finished. They're looking for all the defects. They're looking for all the things that are wrong and trying to make as good as a product in the end as they possibly can. And we need both types of people. We need them to work together. We need the idea creators to get all the ideas, to jot them down, and we need the completers to make them specific, to make them complete. So expectation engineering should be about people working in teams, using their best skills together to work with the expectations. So if we dig a little bit deeper into this expectation engineering, we'll see that what I've done is I've split it up into 2 sub-processes. I'm very much into processes. I actually forgot to mention that I work on the new ISO standard 21119. So, no, 29, sorry, I can't even remember the name now. 29119, which is coming out with a new testing standard. So this has been inspired by that, by the way to phrase a process. So the processes I see in expectation engineering are expressing the expectations and examining them. So at the bottom here you can see that it looks as if expressing expectations is just like standard requirements work. There's some elicitation, there's some analysis, and there's some documentation. But it's not the same. Because if you look at the examination process and compare it to the traditional testing process, you'll see that one of the activities are missing there. In standard testing process, we have analysis and design, preparation of the test, execution, and the actual execution. But in expectation engineering, there's no analysis and design in the examination. All that has moved up to the documentation, the analysis and documentation processes in the expression. So the basic idea is that requirements people and testers, the idea creators and the completers work together to document the expectations in such a way that they can be used directly to extract test cases from. So we do all the analysis in the beginning, and then there's very little left in the examination part. So yes, the expectation expression will take longer than the standard requirements phase. I would say from the small examples, from the small experiments I've done so far, that it might actually take 10–15% longer. But we're still working on the project. We have started the work. And when we get to examination, I guess that we can save about 50, maybe even more, of the standard testing time, because the documentation is there. The documentation is complete. It's ready to be used as test cases and put into test or examination schedules. So you don't have to do all that analysis again and do it very late in the project. So this is just to show that the elicitation, analysis and documentation is a very iterative activity. It's not so that you do some elicitation, some analysis, and then you write the requirements down. You need to go around in circles a number of times, sometimes many times, make a little bit of analysis, make a little bit of documentation, get some questions out of that. How do you mean by this? What can make this requirement complete? Because what we see in many requirements is that they're not complete. They're missing out maybe some parts of the requirements. Very often, testers see requirements saying, in case of such and such, then the system should do this and that. But it doesn't say what it should do if that is not the case. So decisions are dangling and we don't know what the system is expected to do. That is some of the things that the finisher type, the tester type can actually work on in the analysis and go back and ask the stakeholders, what do you think the system should do in the other case? This is just an example of how we can make the expectations complete using some of the techniques that the testers use today. So in the paper that comes with this slideshow, we actually have I actually have listed out what the activities in this process could be, what really is elicitation, analysis and documentation. The other one is the examination process, where we only need to do some preparation. We need to set the test cases together, put them together in a schedule and execute. Again, it's an iterative process. We might have to do this a number of times, but still much less work than what testers do today at this stage in the development life cycle. Now, the expectation engineering process, as I have defined it, is a generic process, and it can be used in different levels of product development. What we need to do usually is to get the foundation, the basic product expectations what is the expectations towards this complete product, and we need to work on them, to refine them, and to map them, to translate them into what are we expecting from the actual system, what are we expecting from the architecture, what is the architecture expected to be like, what are the interfaces expected to be like to meet the system and the product expectations, and what are the expectations towards the construction. In a software system, that will be towards the coding, but it could be towards manuals as well, or hardware bits, or data. So we refine the expectation using the generic expectation engineering process in all the different layers. And this can actually work in different development models. What I have shown here is at the top is how does it work in an agile or iterative development, where you do a little bit of, or you do your expectation engineering on a part of the full set of expectations. You construct a bit of the product, you examine it so that when you start your next iteration, you have a working product and you know what expectations to work on in the next sprint or the next iterative phase. And of course it works in sequential development as well. I think it's very close to what many companies are actually doing when they do agile development. They work together in teams, but I would like them to think about getting testers in there as well to put that completing type of view on the requirements, on the user stories or the traditional requirements. And as I said before, we're using the techniques. So one of the cornerstones of the expectation engineering is to give a lot of techniques and to actually combine the techniques that traditional requirements engineers and traditional testers are using. When I make the courses for both the advanced and the foundation testing and also for the requirements course, I was wondering why we're not using the same techniques. A lot of the techniques that the testers are traditionally using could be used by requirements engineers, or in this case expectation engineers, to help them define or to help them understand when the requirements are complete and when they're testable. So I have worked on a number of techniques. Some of them are very classic techniques that we use today. We need to identify the stakeholders by asking who knows, who feels, who does, who benefits, who suffers. We need to have elicitation techniques like brainstorms, document study, interviews, observations, role plays, workshops, all the classic elicitation techniques. But we don't want to stop there. We don't want to stop with the elicitation results. What we get out of elicitation is maybe business rules, mind maps, minutes of meetings, notes, photos of whiteboards, scenarios, task lists, use case descriptions, and user stories. But they are not complete in the requirement sense or in an expectation sense. So we need to document them and to analyze them. And to do that, we can use some of the analysis techniques that are used today in testing and in design, in architectural design, in detailed design. So we might, for example, use functionality analysis, classification tree analysis to actually make the expectations complete. Boundary value analysis, decision analysis, operability assessment, finding out how accessible or operatable the system is. So using all these techniques in the beginning of the project to get the best expectations possibly. That is what I have worked on. I have tried it out in some different layers, if you like, of the system. So obviously we need to have project management, we need to have configuration management, all the supporting activities under expectation engineering. But apart from that, it's a normal project, just switching the activities around. So what I've done is I have tried this out on some example stuff. I have collected some elicitation results, some requirements, and I've tried to work using these different techniques to see if it can hold in the product expectation level, at the system expectation level, in the architectural expectation level, and at the construction expectation level. So will it work in all these different ways of working with expectations to express them using these techniques and working with them until they're just as complete as a set of test conditions would be, test conditions that are normally made with a lot of hard work and struggle by the testers. This could be done with not so much hard work and cooperation between idea creators and finishers, requirements people and testers to make expectations. And it works. So far, I have managed to do it all the way through. This is just an example of some requirements expressed as notes from a workshop with a secretary, and many of the requirements that I have seen have had this format or been like this, but it's not good enough as requirements. So if we, for example, use the classification tree to model this requirement, it comes out like this. And my guess is that all stakeholders will be able to understand this. If we look at the top, if it says if it's a first time, there's no rebate to be given. That is what the system, the MAMP system, is expected to do. And if it's a regular customer, then there are a number of different cases, different leaves here in the classification tree that express what the system is expected to do. So it has been great this year to work on this. And my guess is that everybody will win from actually taking this working of requirements engineers and testers to the extreme and make expectation teams, because it will make life so much easier for both parties, and hopefully they will end up not being quite as unhappy as they are today. So what I would like to do is to encourage you to think about this, get the paper. It will come up on the website shortly, or send me an email and I can send it to you, and I'll be more than happy to start a blog where we can discuss how this will work in organizations. I'm sort of halfway through writing a book, and I would love to get perhaps a little pilot project somewhere where we can try out these ideas on a real project, or get examples of requirements or design and architecture that we can work on and try and see if we can express them as expectations.
Now, does anybody have any questions for Anna-Mette Haas? Take your time, and maybe Anna-Mette might talk to you about her EuroSTAR 2010 experience.
Oh, yes, I am enjoying EuroSTAR very much. It's like going to a family reunion, and then you get a lot of inspiration and conversation with people, and learn some more. So yes, I'm enjoying it very much. And I can see that I'm getting questions in here. So I have a question from somebody called Vigdis Asbjørnsen. I guess that might be from Iceland, perhaps. So the question is, what is the name of the Requirements Engineering Certificate? And the name of that is IREB, I-R-E-B, International Requirements Engineering Board. It's part of the ISQI, based in Germany, where an organization that's also taking care of the ISTQB and the INTCCM, if you're interested in testing and configuration management. So that is where you can get that requirement engineering certificate. IREP is the name of that. Then there's a question from somebody called Matthias Hollesen. You might be from Denmark, perhaps, or Norway. And Matthias is asking, do you have a process description or checklist of how to start? And yes, I do indeed. In the paper that I have written to accompany this speech, there is a complete-ish description of each of the activities. So for elicitation, for analysis and documentation, and also for the examination, preparation, execution, there are checklists that says what could your input be, what are the activities that you should do, and what is the expected output of that. So I think tomorrow I'll be able to put it on the website with my somewhere in EuroSTAR website, and I'll also start a blog, or you can send me an email and I'll send it to you. So you can start from there. There's a generic checklist, and I have exemplified it for the system expectations, and I actually, in the book, I have exemplified them for architecture and for construction as well. So yes, there are something to start from. Then we have a question here from Donald Stewart, and I can't guess where you're from. This says, hi Anne, do you have anything like the best practice for requirements engineering, like the OASIS document for HPQC? And I'm sorry, I don't actually have anything of that kind. What I work from is the syllabus for the requirements certification. I have actually myself written a book about requirements many years ago, and there are other good books out there, but best practice, no, I'm afraid I can't help you there. Questions keep coming in, and I think, well, I'm not quite sure what this means. Can you help me out? I have two wonderful girls here, three actually, helping me out. So there's a hand here, but not a question. What does that mean?
We have no questions.
Oh, okay. So there aren't any more questions now. I love to get questions, and I'm really grateful for those I've already got. So please, if you have a question, come up with it, and we can discuss it.
I hope you all enjoyed this webinar, which was broadcast live from EuroSTAR 2010. I'd like to thank Anna Mette for a great presentation, which will be available for download on the EuroSTAR website next week. As Anna Mette mentioned, you can also email herself for those slides if you need them sooner. If you have any comments, please feel free to get in touch with us. This webinar is now over. Please hang up your phones. Goodbye.